Hey everyone, welcome to my house. I hope everyone's doing okay. So today I have a lesson that I thought I should record because it's a little complicated. So do you guys remember when we did Venn diagrams at the beginning of the school year? What we're going to do going forward is combining probability with Venn diagrams. And it's not so bad, but I just wanted to explain it a little bit. And to do this, I need to explain a term for you. We had it before. You see, mutually exclusive events. Maybe I should have put an S there. Mutually exclusive events. So what does that mean? Well, when you guys did your Skittles experiment, drawing Skittles, when you put the Skittles back into the bag, they were mutually exclusive events. Why? Because if I pull one of these, I'm not looking, I take one of the Skittles out and I get an orange Skittle. Don't really like orange. Put it back. So the probability of getting, an orange Skittle is how many orange divided by how many total Skittles there are in my little container. But these are mutually exclusive events because if I pull one Skittle out of this container, it can only be one color. I can't have an orange and red at the same time. And it sounds kind of obvious and stupid, but but it does matter, and I'll explain in a little bit. I'll give you some examples of things that are mutually exclusive and things that are not mutually exclusive. So, for example, you guys did, you flipped some coins. This is a really small coin, but when you flip a coin, it can either be heads or tails. So you can't have, they're mutually exclusive because you can't have something being heads and tails when you flip a coin. It's either one or the other. So the probability of flipping one coin and getting heads and tails is 0%. It's either going to land this way or it's going to land that way. Or rolling a dice, what's the probability of getting a 1 out of 6, getting a 2, it's also 1 out of 6, but you can't roll a 1 dice and have it end up both 1 and 2. You get the idea? So it just means that both the events cannot happen at the same time. So what are some events that can happen at the same time? Well, for example, I have some cards here, and there are 4 queens in the deck, a normal standard deck of 52 cards. So the probability of getting 1 queen, if I just randomly pick 1 card, is 4 out of 52. There are, half the deck is red cards, either hearts or diamonds, and there are also these 2 queens. So in this case, getting a queen is fine. Getting a red card is fine. But what if I want a card that's a queen or red? So the problem is with that is that these cards are both red and queen. So that means those are not mutually exclusive events. They're non-mutually exclusive. I have that written out for you. They're non-mutually exclusive events. I don't know why I wrote what's a non-mutually exclusive event. So that means I can pick a card and it can simultaneously be a queen and red. So that affects the probability and it kind of messes with the probability a little bit. How so? Well, here I have, let me get it straightened. Okay, here we go. So here is a Venn diagram to kind of illustrate this. So I have the reds, the queens are in the A circle, so they're 4, and then the red cards are the B circle. Half the deck of 52 cards are red cards, so that's 26 cards. There are 4 queens, but here's the problem. It's backwards. So there are 2 cards that are both queens and red cards. So that kind of messes with it. So what if I want the probability of getting a queen or a red card? What's the probability of getting a queen or red? Well, you guys can just figure it out because you know the numbers. But using the Venn diagram, you can see a problem. We have 4 queens, so the probability of getting a queen is 4 out of 52. When you do OR, you add the probabilities. So 4 out of 52, and then here plus 26 out of 52. But what just happened is that you added this number twice. So now if you weren't smart and you didn't notice that, you could have gotten 4 out of 52 plus 26 out of 52 is 30 out of 52, and that's not correct. So what you have to do when you have non-mutually exclusive events, you have to add the probability of the first event plus the probability of the second event, and then you have to subtract out that extra that you counted twice, because you counted it here and then you counted it here again. So you have to subtract out that intersection once. So that means 4 out of 52 plus 26 out of 52, that's too many, minus 2 out of 52. And here in general is the rule when you have non-mutually exclusive events, when you're doing A or B, you find the probability of the first one plus the probability of the second minus their overlap. And again, just think about it from the Venn diagram point of view. You're taking the probability of A plus the probability of B, and then you have to subtract out that intersection that you counted twice. Okay? So that's it. I'm going to let you practice this kind of simple practice at first, but then it'll get a little bit harder and you'll see why that formula is important. Remember to email me if you have any questions. Thanks, guys. Good luck.